Unit 2, Level 2, Lesson Topic Number 3. What is the connection between inverse, balance, and solving two equations? In this lesson, we are going to build on the idea of inverse and balance to solve not just one step, but two-step equations. So the definition of an equation has not changed. An equation is simply a statement of equality, and that means that both sides of the equation have the same value, and equations only have one solution. What is different is the complexity of the equation. So if you look here, I have 3x minus 2 equals 10. So since an equation is a statement of equality, all we're saying here is that there's one solution, some value for x, that when I put it in here, will make 3 times x minus 2 have the same value as 10. We do this, again, by getting the variable by itself. And how we do that has not changed. We still do this by using inverse operations, right? Inverse addition and subtraction are inverses of each other, and multiplication and division are inverses of each other. What's new today is that we're not separating these into different lessons. You will see all of them together in the equations that we solve. And then, of course, the other thing you need to keep in mind is balance. What you do to one side, you must do to the other. Those two rules still hold. Here's what's new, and this is where you're going to start taking notes. Suppose we're going to solve this equation we've been talking about. 3 times x minus 2 equals 10. Well, we know we have to get x by itself by undoing the operations. But here's the catch. In this equation, look at the operations. How many are there? There's more than one, right? 3x. This is 3 times x, so there's multiplying. And then here we have minus 2, so there's subtracting. How do I know which one to undo first? Does the order matter? And it turns out, yes, order matters. If you recall PEMDAS, which is sort of the acronym for remembering the order to simplify expressions in, right? Parentheses, exponents, and then you do multiplication and division from left to right, and then addition and subtraction from left to right. You go in that order. That's to simplify. When you are undoing equations, like here where you're going to do the inverse, you work PEMDAS in the reverse order. So what does that mean? In your fill-ins on your notes, you want to say you undo PEMDAS in the reverse order. That means that what was last, now you undo first. So with PEMDAS, with the order of operations, you used to do addition and subtraction last. When you're doing inverse operations, you do them first. So make sure you write this down. You're going to undo addition and subtraction first. Then you're going to undo multiplication and division. That's really the only new thing today. Let's look at how it would work. So here's our first equation. We've already discussed this, but you are going to fill this in here. What operations do you see? Well, if we look at this equation, this is the same one that we were just talking about. 3x, that means 3 times x. So we see multiplication and we see subtraction. Now remember, we're going to work PEMDAS in reverse order, right? So that means if I have multiplication and subtraction, I'm going to undo the subtraction first. Please make sure you're writing this down on your notes. You see multiplication and subtraction, you're going to undo subtraction first. So we draw our line down, and we find the subtraction, and we do the inverse, right? The inverse of subtracting is adding. So I'm going to add 2 on the left side. And then what I do to one side, I do to the other side. So I also add 2 to the right side. It looks like this. So I have minus 2 and plus 2. Those cancel out. I am left still with the multiplication. Remember, I haven't dealt with that yet. So I take the 3 times x and I rewrite it down here underneath. Bring down the equal sign. And then on the right-hand side, 10 plus 2 is 12. Now, if you look at this step of the equation, this should look like review because this is one operation to solve and get x by itself. So it should look familiar. Here I have multiplication. The inverse of multiplication is division, so I will divide both sides of the equation by 3. 3 divided by 3 is 1, so I get x by itself. And 12 divided by 3 is 4, so I get that my solution is x equals 4. Next, I want to check. So this is the solution I got, x equals 4. And the question is it correct? Does this side, 3 times x minus 2, have the same value as the right side? And how can we check that? We check that by substituting the solution in for x. So I take x, I replace it with 4, and then I simplify. 3 times 4 is 12, and 12 minus 2 is 10. So sure enough, I have shown that the left side has the same value as the right side when x equals 4. So the solution is correct. Let's look at another example. Example 2. What operations do you see? This is 3 divided by x divided by negative 3 plus 12 equals 17. So here I have division, and then I have addition. So I divided by 3, and then I'm adding 12. So for between division and addition, which operation do you undo first? Remember, you always undo addition or subtraction first. So in this case, I'm going to undo the adding by 12 first. That will be my first step. Make sure you're filling this out on your notes. And then we begin. So we will undo addition first. The inverse of adding 12 is subtracting 12. And then what I do to one side, I must do to the other. So I subtract 12 from both sides. Plus 12 and minus 12 cancel out. I take the x over divided by negative 3 and I bring it down. And on the right-hand side, 17 minus 12 equals 5. Now I have left only division. So I'm going to do the inverse of dividing by negative 3. The inverse of dividing by negative 3 is multiplying by negative 3. And then what I do to one side, I must do to the other. Here, the negative 3's cancel out. I'm left with positive x. And on the right-hand side, 5 times negative 3 is negative 15. Again, to check my solution, I substitute it into the equation. Please make sure you're writing all of this right here that I'm highlighting down on your notes. You write the original equation, you replace the variable with the value that you came up with, negative 15, and then you simplify. Negative 15 divided by negative 3 is a positive 5. And then you add 5 plus 12 is 17. And sure enough, the left-hand side has a value of 17. The right-hand side has a value of 17. So this is balanced. And x equals negative 15 is the correct solution. Example number 3. In this equation, we see here negative 8 times x. So we see multiplication plus 3. So we see addition. We always undo addition and subtraction first. So in this case, we will start by undoing the positive 3, or adding 3. We subtract 3 from both sides. The 3's cancel. I bring down the multiplication because I haven't dealt with that yet. And on the right-hand side, I subtract. 27 minus 3 is 24. Here, I have negative 8 times x. The inverse of multiplying by negative 8 is dividing by negative 8. So I divide on the left-hand side and the right-hand side by negative 8. Negative 8 divided by negative 8 is 1. And our solution is negative 3. Substitute it back into the original equation to check. So I have negative 8 times negative 3 is positive 24 plus 3. And the left-hand side equals 27, which is the same value as the right-hand side, so the solution is correct. Finally, let's look at a word problem. Mary bought apples and bananas. She bought 8 of each fruit. The apples cost 54 cents each. Mary only has $6.64 to spend on all of the fruit. How much can each banana cost? What do we know? It turns out we know almost everything. We know that Mary is buying apples and bananas. We know that she is buying 8 of each kind of fruit. We know how much the apples cost. Each apple costs 54 cents. And we know that Mary's only going to spend $6.64. So the equation represents the cost of the apples, right? 8 apples times the cost of an apple, plus the cost of the bananas, 8 times the number of or the cost of each banana, is going to equal the total. And again, even though we have two variables here, we know the value of A, right? So we don't have to solve for two variables. We know that the apples cost 54 cents each, so we replace A with the value 54 cents. And then you can multiply 8 times 54 is $4.32, and bring that down. Look at what you have here. Even though it's decimals, this is still just a two-step equation. So we know how to solve this. Look for what you see. We have addition and we have multiplication. So I'm going to start by undoing the addition. So I subtract $4.32 from both sides. Even though the 8b is after the plus sign, we don't subtract it because this is the multiplication. And remember, we're going to undo multiplication last. So we leave that alone and subtract $4.32 from both sides. Bring down the 8b. $6.64 minus $4.32 equals $2.32. And now we know that the cost of 8 bananas, 8 times b, equals $2.32. To figure out the cost of 1 banana, we do the inverse operation of multiplying by 8. We will divide both sides by 8. 8 divided by 8 is 1. And we're left with 2 divided by 32 is $2.32 divided by 8 is 29 cents. So the cost of each banana is 29 cents. At this time, you need to complete your summary and then move on to the Google Classroom level 2 practice for two-step equations. When you complete your summary, you need to answer the essential question: what is the connection between inverse balance and solving two-step equations? If you're explaining steps, please make sure that you are giving a reason why. So for example, if you say something like, first, I will add 6 to both sides, you need to add a second sentence that says something like, I add first because I have to always undo addition and subtraction first. Something like that. Give a justification for each step.